All right, so this is going to be a quick and easy way to remember the unit circle. So we'll start just with a circle. So you'll remember from geometry that a circle is 360 degrees. And the formula for perimeter of a circle is 2 pi r, 2 times pi times the radius. Remember, for a unit circle, the radius is going to be 1. And the reason why we use the number 1 is because sine and cosine are bound between 1 and -1. So if that, radius is going in this direction, it's going to be positive. Anything beneath is going to be a negative. And you can try it out yourself in a graphing calculator or a scientific calculator just to, you know, sort of get a feel for it. So yeah, sine and cosine are going to be bound between positive and -1. So another way to write this, we can simply represent it as 2 pi, or 2 pi radians. So this is something that kind of comes in handy that I use as like a mental sort of shortcut. So if we cut a circle in half, we're left with a semicircle, which is equal to 180 degrees. And since it's only half, we can forget about that number 2, and we're just left with pi r. So another way to think about this is pi r radians equals 180 degrees. And I just did a little bit of arithmetic here. So this will be really helpful because when you start to map out your special angles, it might be getting the lingo wrong here, but bear with me. So for example, pi over 2, pi over 3, so on and so forth. What you can do, at least with some of the simpler problems, you can just mentally replace the symbol for pi with 180. So for example, pi over 6, you can think of it as 180 over 6, or just knock the 0 off and you got 18 over 6. 18 divided by 6 is what? 3. And then we just bring that 0 back, and that's a 30-degree angle. Same with pi over 4. So we're left with 180 over 4, or 18 over 4. Knock that 0 off. Well, we already did 18 over 4. And then you can, fill in the blank. So we've got our 2 points where our curve intersects the x and y axes, 0, 1, and 1, 0. Remember, these are all, the radius is going to be equal to 1 all throughout the circle. So a quick way to remember this, what I like to do is I set up sort of a template for all the coordinates, and they all follow the same thing. So we've got a radical in the numerator for both the x and y coordinate, and then a 2 in the denominator. And we place that everywhere around the curve. And then starting from 0, we count up to 4, and then we count back down. So I'll show you what I mean here. So if I go ahead and 0, markers getting a little dry, 1, 2, 3, and 4. And then when we make our way back around, we'll start from 0 and work our way up. 0, 1, 2, 3, and 4. So square root of 0 is 0. 0 divided by 2 is 0. Square root of 4 is 2, and 2 over 2 is 1. And then we've got the coordinates here. Square root of 1 is 1. Divided by 2 is 1/2. Square root of 3 over 2. So we would just simplify these. So if you look at a formatted unit circle, usually these are simplified. But if we don't simplify, these square roots, it's a bit easier to look at. But this is just a handy way to kind of look at it. One other thing I wanted to mention. So one way I'm able to remember that cosine refers to the x coordinate and sine refers to the y. It may not make much sense, but in my head, sine kind of rhymes with high or y. So I just remember it that way. Like when I see sine theta, I think of a y, think of a y value. And cosine, I just tell myself it's the other one. So sine kind of rhymes with high, and then, I kind of work backwards. So hopefully this helps. I did this on the fly, so if there's anything I missed or got wrong, please leave a comment.